Hello there. How's everyone doing? Let's go ahead and get started on this. We have quite a bit of semester left. The format has changed, but the content has not. So, welcome to our ongoing discussion on distributions. We were dealing with binomial distributions before the break, and now we're going to get into normal distributions. First, though, let's put everything into perspective. Why do we do what we're doing now? And so I want to bring our attention all the way back to the very start of the semester when we discussed what the purpose of statistics might be. And that for us is this: the job of statistics and us as statisticians is to make meaningful conclusions out of incomplete or imperfect data, right? If you have all the data, it's not statistics anymore. If you have all of the data, we call that a parameter. But if we have imperfect data, incomplete data, that's when we still have to make sense out of what we have, and that is the job of statistics. So from there, we went into things such as mean, median, mode, variance, standard deviation. And those were all different ways of grasping at how our data is acting, right? The mean, median, and mode would tell us the center of our data set, and the standard deviation or the variance, right? You square one, you get the other. That will tell you how spread out the data is. But now we want to look at how that data is actually spread out. Obviously, if you have a low standard deviation, it's close to the mean. If you have a large standard deviation, it's far away from the mean. But is it a gentle tapering off? Is it abrupt? Is it up and down? And that's what we want to look at now. How does our data actually look? So we're going to start with the simplest possible example, the uniform distribution. Right? A uniform distribution is any type of situation where all of your outcomes are equally likely, like what I have right here. I'm looking at a birth set by month at a local hospital, January, February, all the way through December being the 12th month of the year. And the heights of each of these bars are the same. And I know what you're thinking. No, Mr. Terrell, it absolutely is not. Look how high this bar is for 11 versus how short this bar is for month 10. But I throw this up here for a couple reasons. First of all, I want you to imagine and hopefully agree with me that there are not relatively more months in March than April, and so on and so forth. There should be a uniform distribution of months and births. Secondly, I wanted to bring this graph up as a reminder that all the things we've learned so far still apply. In particular, I want us to make sure that the graphs we're looking at are not misleading. And if you look carefully at this graph right here, it doesn't start at 0. It starts at 0.08 or 8%, and it goes up to about 9%. So this whole graph only spans about 1% for probability. So perhaps a better graph, a better representation of this same situation would be to start at 0% and go up to about 10%, like we have here. Same information, just graphed in a less misleading way. And hopefully now we can all agree that, yeah, this is pretty uniform. This graph is pretty uniform. There's about the same number of births every month. And so, because of that, what we could do with this data, right, take the height of each of these, take the numbers for each probability, if we just averaged out those probabilities, we would get a true uniform distribution. And so that's what we're going to do for uniform probability here, uniform probability distributions. We can take all of the probabilities and set them to be equal to each other. And that will make our first distribution. So I think we'll stop here, just soak up what I've just said, and we will get into the other probability distributions in the next video. So for now, we've got uniform distributions, which is just a nice flat line all the way through all of the outcomes. And the height of that line is just the average probability. And there you go. That's all it's going to be. We will get more into the hard and fast arithmetic of it in the next video, and we'll start exploring the other types of distributions as well. I'll see you up ahead.